So 5.1, graph of sine and cosine and tangent. These are trigonometric ratios. Let me just bring another page, new share. So just quickly recap, if we have a unit circle, see, this is my unit circle. Each point has a coordinate, right? This point, what is it? Is 1, 0, which is 0 degree, right? The angle here is 0 degree. The angle here is 90-degree angle. So that's what it is, 0, 1. Here is 180 degree. The angle is 180 and the point is -1 and 0. And here is 270 degree. The angle is, so the point is 0, -1. And here we go back to 360. 0 is the same as 360. When you do full circle, from here to here is 360. Now, before I did show, I want to make, this is kind of, we have done it before, just remind you. If we have a unit circle and any point on this has x and y, the angle here is theta. So from here to here is y component. From here to here is x component, right? And because this is unit circle, the radius is 1. So it means the hypotenuse of this right triangle angle is 1. So sine theta is opposite over hypotenuse, right? Opposite of that is y over 1. So it's just y. Cosine theta is adjacent over hypotenuse. Adjacent here is in right triangle is x over 1. Tan theta is equal to what? Y component over x component, or sine over cosine, but you know that is opposite over adjacent. So let's say I want to graph y equal to cosine theta. I need to have some point, right? What I do for theta and for y. 0 degree. See, cosine is x component. Means the x component of 1 and 0 is what? So 0 degree is here. The x component is 1. So here is 1. The next one is pi over 2 or 90 degree. Let me just put the pi over 2. But you know pi over 2 is 90 degree, right? Theodore, can you tell me what is the cosine of the 90 degree? If you look at that, this point.
Cosine 90 degree.
How did I do that? I did cosine of 0 is 1. I did the cosine is x component. I just look at the x component is 1, right? Now cosine of the 90 degree, you have to look at here. What is the cosine of the 90? So you have to look at the x component. What is it? X component here?
0.
0. Give me the next one. For 180 degree. 180 degree is the same as pi. What is the cosine of 180 degree? You have to look at here. X component. What is it?
180.
-1. X component.
Oh, okay. Oh,
-1, right?
Yeah.
270. What is the code?
0.
Yes.
Oh, I know that.
Yeah, it's 3 pi over 2. So this is the angle that I put in radian, right? Is 0. How about 360? What is the cosine of 360 or 2 pi? What is it?
It's 0. Wait, it's
Excellent.
1.
It's 1. See, cosine is x. You have to look at the x is 1. So this point I have, I can graph it, okay? Let me just put that. The point I have is what? Is start from 0, pi over to 1, 2, 3, 4. So here is pi over 2. Here is pi. Here is 3 pi over 2. And here is 2 pi. I can go further, but one cycle is enough for me to graph. So 0 is 1. So let's just put my 1 to be here. So 0 is 1, means this point. 0, 1. Pi over 2 is 0. Pi negative 1. So let's see, negative 1 is there. 1 is here. So this point. 3 pi over 2 is 0. 2 pi is 1. See, when you're graphing this, you have to curve it. This is maximum. This is your minimum point. Again, this is going to be your maximum, right? You can continue. See, again, this will go to 0 if you continue. This is repeating, right? Then it go to negative 1. Then it go to 0. You can continue this way. You can continue at the other side as well. So here is negative pi over 2. Go to 0, right? And so on. This is a periodic and it continue forever here, continue forever at the other side. Any question?
No.
No? So another one is, this is cosine. I can do sine. Let me just do the sine here. Let me just move that there. Y is equal to sine theta. Again, I can do the points. I put them in the radians. So here is theta, here is y. I do for 0 degree. I do for 90 degree. 90 degree is pi over 2 again. Pi is 180. 3 pi over 2 is 270. 2 pi is 360. Now, knowing that the sine is a y component, can you tell me what is the sine of 0 degree? See here, the 0 degree is here, right? Sine is y component. What is the y component here? 0. Yes.
0.
Now tell me, what is the sine of the 90 degree or pi over 2?
90 degree.
90.
1.
Yes. What is the sine of pi? Or 180?
180 negative 1.
Pardon?
Negative 1.
Here, y
Negative
component.
1.
Y component. Sine is y component. What is the y component here?
Or 0.
0.
Okay, not x.
Yes. 3 pi over 2. What is the sine of 3 pi over 2 or sine of 270?
Negative 1.
Negative 1. What is the sine of 2 pi
Negative 1.
or 360?
0.
0. So I have these points. I'm gonna graph that again. So 1, 2, 3, 4. So it's pi over 2, pi, 3 pi over 2, and 2 pi. So for 0 is 0, so you start here. Pi over 2 is 1. Just put 1 here. Pi is 0. 3 pi over 2 is -1. 2 pi is 0. Again, you have to curve it. Don't put a straight line. So many students do that. It's curved,
Okay.
right? It's curved like that. You can continue again. You just do for one more. Just go to what? Go to maximum 1. And if you can just, continue from here, it's gonna continue like that. Go to -1. And then this one, you can go down and so on. This is the sine. Now for tan, just put a line here. So y equal to tan theta. Again, we need to do the points, right? So theta, and here is y. We do for 0 degree, we do for 90 degree or pi over 2. We do for 180 or pi, or 370 or 3 pi over 2. And for 360 or 2 pi in radian. So be careful, tan is y component over x component, right? If I ask you what is the tan of 0, you look here, y component over x component is 0 over 1, okay? 0 over 1, which is 0, right? Now, can you tell me for pi over 2 or 90 degree, what is the tan of the pi over 2? For 90 degree, you have to look here, right?
Tangent.
Tan is y component over x component. What is the y component or x component here?
1,
1 over?
1,
Over
1
0.
over 0.
Yeah, y component over x component, 1 over 0. 1 over 0, since the denominator is 0, is not defined, or this is an asymptote here. How about pi? What is the tan of pi or 180 degree?
0 by -1.
0 over -1, which is equal to 0, right? For 3 pi over 2.
What?
Or 270. 3 pi over 2 is 270.
-1, 0.
-1 over 0, because the 0 is in denominator is not defined, or it is your asymptote. For 2 pi or 360.
0, 1.
0 over 1, which is equal to 0. Very good. Now for the graphing, you know, the one that is ND means just as your asymptote. Let me just do that here. Different color I do. So here is pi over 2 again. Okay, 1, 2, 3, 4. And here is that. For 0 is 0. So this is the point. Pi over 2 is ND, means you have an asymptote. You just put a vertical line, a dotted line like that. Means you never cross this line. For pi is 0, 3 pi over 2 is again asymptote. So this is 3 pi over 2. This is pi. But this is an asymptote again. And this point is 0. It's 2 pi. Now, in first quadrant, so cast rule, remember cast rule, right? CAST. In first quadrant, everything is positive, right? From 0 to pi over 2 is your first quadrant. Since it's positive, you have to go up toward asymptote. You don't go down. If you go down, become negative, right? In first quadrant, the tan is positive, so you have to go up toward the asymptote. Here is 0. In the second quadrant, just the sign is positive, means your tan is negative, right? In second quadrant, from here, you have to go toward the asymptote. You have to go down because the tan here is negative. Now, in a third quadrant, your tan is positive. CST is up, right? You have to go up because you need to be in positive side. Then in the fourth quadrant, from 3 pi over 2 to 2 pi, just cosine is positive. That's why you have to go toward, from this point, you go toward your asymptote, but in negative side. You go down. You can repeat that since, you know, just the pattern is very clear. You have an asymptote here. You can really go ahead and draw the rest of that. So here, then you go toward the asymptote. Again, here you have an asymptote. You go up toward the asymptote, right? See, we have characteristics here from the sine. The period is one full cycle. Period of this is equal, I show it with P, is from 0 to 2 pi, right? So it's going to be 2 pi, the length of one full cycle from here to here, we call it period. The period here is from 0 again for 2 pi, because after that, it will repeat itself. So from here to here is period again. So period again here is going to be 2 pi. Period here, see, this is going to be from negative pi over 2 to pi over 2, because this is repeating, right? From negative pi to pi over 2, then it's repeat from pi over 2 to 3 pi over 2. Is your period going to be from this distance? This is your period. This, the length between negative pi over 2 to pi over 2 is pi. So period here is the length of the full cycle is pi. Now, talk about the maximum point. Here, the maximum point is 1, right? Maximum point is 1. And minimum point here is -1. Same thing here, maximum is 1. Minimum is -1. Here we don't have any maximum or minimum because this will go up forever. This is go down forever. So max we don't have is n. Minimum we don't have because it's going down forever. Now amplitude. Amplitude is the half distance between maximum and minimum. See, the distance between the max and minimum is 2, right? Half of that is 1. So A amplitude is 1. So it's just half the distance between the maximum and minimum. So here is amplitude. And here is the amplitude, the half the distance between maximum and minimum. As you see here is the amplitude is 1. But do we have amplitude in tan? No. Let's go up forever, down forever. No amplitude. A, we do not have it, right? Any question, Theodore?
No.
You want to take a screenshot quickly?
Yeah.
So here's for the worksheet, see, it says sine every 0.5. Ignore, just graph the sine for me here. Just one of that, right? Here we have 2 sine. Just do one of this. And then tell me y-intercept, amplitude, x-intercept, period. Those information, fill it up. Do cosine. Again, we have two of them, but just do one of that. Then you just see if there is any asymptotes. Talk about the domain, range, and period. Then tangent. You graph a tangent and you just give me this information again. You graph cotangent, just fill up this information. You don't have to do twice, just do one of the tan, one of the cotan, right? You got it?